Hello all. In this video, we will study how to calculate referencing environment of a procedure in a statically scoped language. So consider the following pseudocode. You can see we have three procedures defined. Procedure A, which contains two parameters A and B, and it also contains a local variable X. Then procedure Q, which is defined in procedure P. Q takes two parameters B and C and contains a local variable Y. Then we have procedure R, which is defined in procedure Q, which contains two variables as parameters A and C, and Z is a local variable. Okay, this is code for procedure R, right? This is code for procedure Q, and this is code for procedure P. So we have three procedures P, Q and R. Okay, so let me clear the ink. Okay, now the question is, we have to assume that the language is using static scope rules, and we want to know what is the referencing environment marked by star. So this is the star mark. So you want to know the referencing environment over here. Now, as I already told you that this code belongs to R, we need to find out referencing environment for R. Now, since R is defined in Q, we need to find out first referencing environment for Q, then only we will be able to find out the referencing environment for R. But in order to find out referencing environment for Q, we see that Q is defined in P. So we must first find out the referencing environment for P, and then only we will be able to find out the referencing environment for Q. So although the question asks you to compute referencing environment for R, it eventually asks you to first compute referencing environment for Q and then referencing environment for P. So first we have to calculate referencing environment for P, then we will calculate referencing environment for Q, and finally we'll compute referencing environment for R, which will be our final answer. Okay, good. So let's compute the referencing environment for P. Okay, so I'll write referencing environment. Okay, first I'll compute referencing environment for P. As you know that referencing environment contains two portions, non-local and local. NL stands for non-local, L stands for local. Now the non-local referencing environment for P will be nil, right? Non-local referencing environment for procedure P will be nil. Why? Because P is the first procedure defined. We are talking about static scope rules. So P is the first procedure defined. P is the outermost procedure. P is playing the role of main. P is not defined in any other procedure. So P is the first procedure defined, hence it does not have access to any non-local variables, hence its referencing environment is nil. Whereas when you think of local referencing environment, it has A, it has B, it has X. So it has access to P's A, P's B and P's X. Okay, so that is the referencing environment for P. Now we have to calculate referencing environment for Q. First we will calculate non-local referencing environment. Now as we know that Q is defined in P, everything from P is copy pasted into the non-local compartment of Q. So we take P's A, we take P's B and we take P's X. And then we think of computing the local referencing environment. Q has its own copy of B, so it has Q's B. Since it has its own copy of B, it won't access P's B, right? It has its own copy of B. Then it has its own copy of C, so Q's C, and we have Q's Y. Okay, and then we have to calculate the referencing environment for R, wherein first we think of non-local compartment. As we know that R is defined in Q, everything from Q is copy pasted into the non-local compartment for R. So what we take is P's A, P's X, then Q's B, Q's C, and Q's Y. And now we think of its local referencing environment. It has its own copy of A, so it is R's A. Since it has its own copy of A, it won't access P's A. Then it has its own copy of C, so R's C, so it won't access Q's C. And then it has its own copy of Z, so R's Z. Right? So this is our final answer. What is our final answer? That the referencing environment at this position is, you can access P's X, you can access Q's B, you can access Q's Y, you can access R's A, R's C, and R's Z. Okay, I hope you have understood. Thank you.